Today I will show the catchment delineation of Pioneer Creek located at Tilapia. I'm searching for the DEM that suits the subject area. That's my subject area. I can draw a box to search DEM file of the subject catchment. Here I can see there are few DEMs, but my interest will be in first and second, so that I can download those and join those DEMs to create single DEM, and then I can simply extract the subject site DEM special data. They send a link to your inbox provided email, and you can simply click the link to download the DEM data, which is quite straightforward procedure. The downloaded data can be extracted to the working folder, and then necessary action can be taken. I'll simply paste it to the working folder there in DEM and extract it. I extract it. Okay, there's a folder and the DMs are inside the folder there. I simply copy those and paste to the working directory there. I'll not keep longer folder paths, so the QGIS will be configured efficiently. Open QGIS, and now we can join the DEMs. It's taking time. There you go. Here we have files, DEM files within QGIS folder, DEM and Pioneer Creek. Those are two DEMs. They are loaded in QGIS interface. I can just join those using build virtual raster there, but I will search it from processing toolbox and find the build virtual raster there. I can choose the 2DEM as input. I can simply click OK there, and I will name the virtual raster as DEM mosaic and placed it in the working directory there. Simply I'll call it DEM mosaic. And set. I can get rid of the individual DEMs because they are already joined by build virtual raster. I can just have a background map over here to confirm the location is correct. I can change the transparency of the DEM to see the exact location there. EM, that's my subject site, so I can proceed ahead with clipping the raster. So I'll search clip raster by extent. That will be useful now. The input layer will be DEM mosaic, and I will draw selection within the interface so that I can choose my subject area very concisely. That would be enough in my opinion. So I will save it as DEM only, and I will save it in TIF format. Now I will extract this DEM to the working folder so that I can delineate the catchment using this DEM in HECHMS. I simply export, save as GOT if that's correct, and then save it to the working directory. I will save it as DEM vineyard. That's correct. That's good. Then I just check if there is DEM or not. Yes, that's our DEM. So I'll create a new project there. I'll name it Catchment, but it will be misunderstood. So let's say Vineyard Creek, and the file location, the project location is at HECHMS folder. The HECHMS file create. Create a basin model manager. I simply name as Catchment. I'll define terrain model manager as well. I will import terrain from Vineyard Creek setting. That's our terrain. Now I'll define terrain within the catchment. We need to set the projection system first. I have the projection system already saved in one of my save files. I can use that one because both projection systems are same. Now I can simply choose terrain in the catchment. If I click terrain, the terrain is displayed within the HECHMS. Now I can proceed with GIS features. The first is to fill sink. It will fill any depressions within the DEM. The second step is to calculate flow direction and drainage lines. We can see the drainage lines over there from different cells. I think that is our power point, the drainage point. So I can just simply uncheck flow direction, sink location, sink file, just to see flow accumulation only. That is our subject drainage point. Okay, now we can proceed ahead with identify streams. For that we need to define the sub-basin or sub-catchment area, i.e. 0.05 kilometers square, and it will identify streams for 0.05 kilometers of basins. I can visualize the streams. They are nicely formed. Yes, our subject drainage point is somewhere near the junction. We can provide breakpoint manager. We can simply import from the file source over there, and also we can define PowerPoint from HECHMS itself. We can import zip file from outer link. I'll click to define drainage point there. I'll simply click create, and the drainage point is formed. Now I can delineate the basins. I'll provide sub-catchment as the sub-basin prefix, and I'll simply say ridges or simply ridge. Yeah, our catchment is delineated with sub-basins, sub-catchments over there. Now we can export these sub-basins, river ridge, drainage point to QGIS for the further calculation. To do that, we need to export this one, but I'll show you the merge feature of HECHMS. We can simply merge the sub-basin which are interrelated. For example, the one I clicked can be merged with adjoining sub-catchments. I can split as well, but for now, to reduce the number of sub-catchments, we'll merge it. I can simply file here. I'll create a file called zip file within the project. Zip file. I'll simply save sub-catchments there. I'll choose the folder here and then name sub-catchment. Sorry, catchments. I can also export the river ridges. I'll call it rivers or creeks, let's say. I can also export the breakpoint. Identify streams as well. All the streams within the catchment, and finally I can export breakpoint as well, which is drainage point. I can merge the catchments, sub-catchments like that. Now we can open the delineated catchment within QGIS. And that is our subject catchment, the drainage point, all the identified streams and streams within the catchment. I can simply change the color and see it's our catchment. I'll change the color to blue for the river lines and the flow path of the creek, and I can simply uncheck all streams. By opening attribute table, we can have area, which is really useful, and all the information as well. That's our subject area and catchment. I think there is a small DEM over here so that we can see what pond is over here. Subscribe for the new videos as well.